Welcome to Universe Unlocked, where we look beyond our pale blue dot and ask the big questions. Today, we're tackling one of the boldest ideas humanity has ever dared to imagine: colonizing Mars. Not just visiting, not just planting a flag and going home, but actually staying, living, thriving. Now, I know what you might be thinking: why Mars? Why not fix Earth first? Why not focus on problems down here before we start packing our bags for a colder, redder version of the Sahara? Well, let's start there, because the truth is, it's not about abandoning Earth, it's about protecting our future. Earth is beautiful, but it's vulnerable. One giant asteroid, a supervolcano, a deadly pandemic, nuclear war, or even a rogue AI deciding humans are inefficient. Any of these could wipe us out. Depressing? Yes. But realistic? Also yes. Mars represents a kind of insurance policy, a plan B. Not because we want to leave Earth, but because we may one day have to. But it's more than that. Colonizing Mars is the next natural step in our evolution. Humanity wasn't meant to stay in one place. We crossed oceans, scaled mountains, flew across continents. Space is just the next frontier, the ultimate challenge. And Mars? Mars is the most achievable stepping stone to becoming a spacefaring civilization. It's close enough to reach in months, not years. It has polar ice caps, it has seasons, it has the raw materials for survival, and crucially, it's just hard enough to push our limits, but not so hard that it's impossible. So how would we actually do it? Let's break it down. First, transportation. We'd need powerful rockets, reliable propulsion systems, and lots of fuel. SpaceX, NASA, and other agencies are working on reusable spacecraft capable of reaching Mars with cargo and humans. Think of SpaceX's Starship like a next-gen interplanetary Uber, if your Uber cost billions of dollars and came with its own launch pad. But getting there is just step one. Once we arrive, we need to survive. Mars is freezing. Average temperatures hover around minus 60 degrees Celsius. The air is 95% carbon dioxide. Atmospheric pressure is less than 1% of Earth's, meaning if you stepped outside without a suit, your blood would literally boil, not from heat, but because there's so little pressure holding it together. Not ideal. And don't forget the radiation. Unlike Earth, Mars has no global magnetic field to shield us from cosmic rays and solar storms. That means we'd need thick-walled habitats, regolith shielding, or even underground bunkers to avoid the long-term risk of cancer, cell damage, and other delightful side effects of space exposure. That's why we'll need habitats, pressurized, shielded, temperature-controlled structures that can keep us alive. These could be underground bases carved into Martian rock, inflatable domes covered in regolith, or even structures 3D printed using Martian soil. That's not sci-fi, that's a real area of research happening right now. And food? Can't exactly order a pizza to Gale Crater. We'd have to grow crops in Martian greenhouses using hydroponics or aeroponics, systems that use water and nutrients without traditional soil. Experiments on the International Space Station have already proven we can grow lettuce in space. Water is critical. Luckily, there's frozen water under the surface, especially near the poles. And from that water, we can also make oxygen to breathe and hydrogen for fuel. Every drop is precious. No long showers on Mars. Energy? Solar power will be key, as long as we build systems that can withstand the occasional global dust storm that blocks out sunlight for weeks. Nuclear energy might also be a solid long-term backup, reliable, compact, and not affected by weather. Then there's gravity. Mars has about 38% the gravity of Earth, enough to keep you grounded, but not enough to prevent long-term health problems. We don't fully know how low gravity affects the human body over decades. We might face muscle loss, bone weakening, even changes to our hearts and brains. Regular exercise, artificial gravity systems, or genetic tweaks might become essential for Martian health. But what about the long term? Is it possible to terraform Mars to make it Earth-like? In theory, yes. The idea would be to warm the planet by releasing greenhouse gases, maybe using orbital mirrors to concentrate sunlight, or unleashing CO2 trapped in Martian soil. This could thicken the atmosphere, warm the surface, and eventually allow liquid water to exist. But scientists estimate even a basic version of this could take centuries, or millennia. Still, the process of partial terraforming could help. Even modest increases in pressure and temperature could allow crops to grow outdoors in pressurized greenhouses, or make outdoor travel less dangerous. Think of it as upgrading Mars from instant death to mildly survivable with good gear. And speaking of people, who goes first? Who should go first? Scientists, engineers, farmers, artists, Probably all of them. A Martian colony won't just need brains, it'll need culture, community, creativity. Colonizing Mars means building an entire society from scratch with everything that makes us human. Of course, there are ethical questions. Should we even colonize another world? What if microbial life already exists there? Do we have a right to change it? These are the kinds of debates humanity will face as we take our first serious steps into becoming an interplanetary species. But here's the big picture. Colonizing Mars is not just about Mars. It's about pushing the limits of our technology, our willpower, and our imagination. The breakthroughs we develop for surviving on Mars, better energy, better recycling, more sustainable living, could help us fix Earth too. And maybe that's the greatest irony. By learning how to survive on another world, we may finally learn how to take care of our own.